Alright, so yesterday we took that quiz, which I have, and I'm going to hand back shortly for those of you that were here. And we started 5.3. So we have the sine and, or the cosine sum and difference formulas that we wrote down. We did the first couple examples on that. So let's look at example C. I think that's where we're ready to pick up. So this one is already expanded out. If you look at your formulas, I have cosine times cosine plus sine times sine. So look at your identities for cosine, sum, and difference. Both of these have cosine and cosine, then sine and sine, but which one has a plus in the middle? The difference formula. So this is the cosine of A minus B formula. So my A, my first angle is 173, minus B is just my second angle, 83. 173 minus 83 is 90. Cosine of 90. So think about your hand trick. If you fold on your 90, it's the square root of 0 over 2, which is just 0.
Wait, which formula is A minus B? Because I messed up the A plus B for both.
Oh. So on these
Okay, thank you.
All right, are we good with that one? Let's do a proof with these. So the proof thing doesn't really go away. We can still use these. If I look here, we try to box in the simpler side. So which one would that be? Right, cosine x is definitely easier. So on the left I have cosine of something plus something. So we can use that cosine of A plus B formula to expand that. So that's cosine of the first times cosine of the second minus sine of the first sine of the second, using our formula from yesterday. Is everybody okay with that? So 2 pi is right here. That's the same as 0. So you can use your hand trick. You can think about the unit circle. Cosine is the x. What is cosine of 2 pi, or the cosine of 0? 1 minus sine of x times, what is the sine of 2 pi, or the sine of 0? So cosine x times 1 is cosine x, minus sine x times 0 is just 0. So we get cosine x. Questions? Really just a couple examples. because this is a subtraction, that's the cosine of A plus B, cosine sum formula. So my first is 3x, B is 2x, 3x plus 2x, 5x, so that's cosine of 5x. So we'll just go through some examples and practice using these things. So the first couple are like what I did yesterday with the cosine. When I ask you to find the exact value, that means not a decimal from my calculator, but with radicals. And I have negative 15 degrees. So I'm thinking about, on my unit circle, what are two angles that would add or subtract to 15? To negative 15, sorry. Yeah, we could do 30 minus 45. That would give me a negative 15. 30 and 45 are both angles we have on our circle. Okay, one thing I want to caution you on, we aren't treating this as a negative 45. We're looking at the fact that this is a subtraction means I have to use the subtraction formula. Okay, so that is sine of A, so sine of the first, cosine of B, so cosine of the second, because this was subtracting, if you're looking at the difference formula, that is a minus cosine of the first, sine of the second. Does everybody understand how I expanded that? So then we can evaluate. So think about your hand trick. 30 degrees. Sine is the square root of the top over 2, so square root of 1 over 2 is 1/2. Cosine of 45, so 45 cosines the bottom, so radical 2 over 2. Minus cosine of 30, so fold in your 30, cosines the bottom, radical 3 over 2. Sine of 45, which is radical 2 over 2. So multiply the tops, we get radical 2 over 4 minus radical 6 over 4. The only other thing you could do is make those in one fraction. Otherwise, that's all we can do. You'll notice all of our answers are kind of looking very similar on these. We have a lot of radical 2s, radical 6s, over 4, and that's because our common angles. You know, we're using 30, 45, and 60, so we're doing 1/2 radical 2 over 2 and radical 3 over 2. We're using the same reference angles every time. So all of those answers are going to turn out to be very similar. So this is just a matter of using your formula and then evaluating like we've been doing since the beginning with our hand trick or unit circle options. Other questions on A? And if you copied down a formula wrong or something, if you need to double check them, these are on page 216 in your textbook if you flipped a sign or something. All right, B. We had one yesterday that was in radians, and we said it's really hard to think about what would add or subtract to give us a fraction. So what did we do to make that easier? Change to degrees. So 13 pi over 12, we could change that to degrees by multiplying by 180 over pi. So the pi's cancel. 13 times 180 divided by 12. What does that give us? two angles from my unit circle that add or subtract to 195. So if you need to, you should have a copy of the unit circle you could pull out and look at.
1545.
Okay. So this is a plus. That means my formula is the tangent of A plus B formula. So if we're looking at that, it's tangent of A plus tangent of B over 1 minus tangent A tangent B. All of these formulas are given on the formula sheet, so you will not have to memorize any of them. All right, so my A is just this 150 and my B is 45. So plug those into the formula. So tangent of 150 degrees plus the tangent of 45 degrees over 1 minus the tangent 150 degrees times the tangent of 45 degrees. 150, what quadrant is that in? 2. What's our reference angle? 180 minus 150 is 30. Okay, in quadrant 2, tangent is negative, tangent of 30. So remember, tangent's the square root of the top over the square root of the bottom, so radical 1 over radical 3, or radical 3 over 3. Plus the tangent of 45, so that's radical 2 over radical 2, which is 1. Over 1 minus tangent of 150, we already got negative radical 3 over 3, times the tangent of 45. Okay. The sine and cosine formulas, your answers are going to be pretty straightforward. The tangent formula can get ugly. So I want to talk about what I expect in terms of your final answer on these. I do not want a fraction in a fraction. There is a really easy way to get rid of this. We use it sometimes with proofs. We can multiply the top and the bottom by the same thing. What do you think I would multiply by to get rid of the fraction? Just 3. You could just multiply by the denominator. So negative radical 3 over 3 times 3 is just negative radical 3. 3 times 1 is 3 over 3 plus radical 3. Technically, it is not proper notation to leave a radical in the denominator. I will allow you to leave your answer there, okay? I want you to understand, though, if you're checking with a neighbor, they may have an answer that looks different because we didn't go all the way and get the radical off the bottom. You know, if you wanted to get that radical off the bottom, you would have to multiply by the conjugate. And if you did that, we would have, let's see, 9 minus 6 radical 3 plus 3 over 9 minus 3. And that would reduce to 2 minus radical 3. And that is the best answer, but I am not going to make you go that far. So you can leave it like this. Technically, there is another equivalent form that might happen if you had different angles that you added. So if you're trying to compare with the back of the book or a partner and see if you got the right answer, what you can do is plug these into your calculator and see if they have the same decimal equivalent. So I ask that you get rid of any fractions within your fractions, but I'm not going to stress out about it if you leave a radical in the denominator, because that's really not my focus right now. I just want to make sure you can use the formula. Does that make sense to everyone? Okay. Let's look at C. What does this look like to you? This is the tangent of A minus B formula. So A is just your first angle and B is just your second. So we can turn this into the tangent of 100 degrees minus 70 degrees. 100 minus 70 is 30. And what is the tangent of 30 degrees? So we can work both directions with this. Do we need more examples along this line? Let's try this one. I may not do all of these, we'll do a few of them. So I want to still use these formulas to basically simplify this as far as we can. So the sine of 120 degrees plus theta. What would we have to do here? That's our A plus B. So the A plus B formula is sine of the first, cosine of the second, minus, did I put cosine or sine first when I gave you the formula? Just want to make sure I write it the same way I gave you. I did cosine. Cosine of 120 degrees, sine of the second. Okay.
Why'd you put a minus there?
I don't know. How about a plus? Because I was checking the homework that I wanted to assign at the same time as I'm writing, and I wrote a combination of problems. Okay, 120 is in what quadrant? Reference angle, 180 minus 120 is 60. In quadrant 2, is sine positive or negative? All right, and then the sine of 60 degrees? So we have radical 3 over 2 times the cosine of theta plus, okay, in quadrant 2, is cosine positive or negative? Negative. So you could say plus a negative, or if you wanted, you could go ahead and just change that to a minus. What's the cosine of 60? 1/2 times sine of theta. That is as far as we can go here. So that is our final
How
answer.
did you get that second part when you switched the negative to a positive and then 120 turned into 1/2?
Okay, so 120 is in quadrant 2.
Okay, did you just do 180 minus 1? Okay.
So that's the cosine of 60, so that's 1/2. And I made it a negative because in the second quadrant, if you think about cosine as your x, so it would be a negative.
Okay.
All right, let's try, we'll do B, if I want to. Okay. So which formula is this? Tangent of A plus B formula. So my A is just theta, my B is 3 pi. So that's tangent of A, so tangent of theta, plus tangent of B, so plus tangent of 3 pi, over 1 minus tangent of A times the tangent of B. Okay, we need to simplify as much as we can. So the only thing we're really going to be able to do is simplify that tangent of 3 pi. 3 pi is the same as what? Okay. Anything bigger than, like if it's in degrees, if it's bigger than 360, we subtract 360, right? In radians, all the way around the circle is 2 pi. So 3 pi minus 2 pi is pi. So we're right here. Okay, that is the point -1, 0 on our unit circle. Remember, tangent is y over x. So 0 divided by -1 is 0. So we have tangent of theta plus 0 over 1 minus the tangent of theta times 0. So the top is just tangent of theta. On the bottom, it's just 1 minus 0. So this is just equal to the tangent of theta. Are we okay with these problems? I'd like to do one proof and then I'm done. Which side would you box in? Yeah, they're both kind of ugly, aren't they? When we do proofs with these, anytime you have angles that are adding or subtracting, I would, so when I have tangent of something plus something, I would work that side because we have formulas to expand it. So that would probably be the easier option. So I'm going to box this in. Now we may have to end up working both sides because they both look pretty ugly, but we'll see where we get to. So tangent of, this would be tangent of A plus B. So that formula is tangent of A plus tangent of B over 1 minus tangent of A times the tangent of B. Plus, this is the tangent of A minus B formula. So that's tangent of A minus tangent of B over 1 plus tangent of A, tangent of B. Okay, pi over 4, that's like 45 degrees. What is the tangent of 45 degrees? 1. Radical 2 over radical 2, which is 1. So every one of these tangent of pi over 4s, I can change to a 1. So that'd be 1 minus, or 1 times tangent of t on the bottom. Common denominator. So this one has 1 minus tangent. We practiced one of these before your quiz yesterday because I told you you would have one on your quiz. If this has 1 minus, it needs 1 plus This one has 1 plus, so it needs 1 minus. So if we FOIL, we get 1 plus tangent t, and plus tangent t is plus 2 tangent t plus tangent squared t. And that's 1 minus tangent squared t. This one, when I FOIL, I get 1 minus 2 tangent t plus tangent squared t over 1 minus tangent squared t.
So how do you, I always get confused, like when you like FOIL it, and like the tangent t times tangent t, how's that 2?
So,
and not 2,
okay.
do this.
So, when we FOIL these, 1 times 1 is 1. 1 times negative tangent t is negative tangent t. Negative tangent t times 1 is negative tangent t. Negative tangent times negative tangent, so negative times negative makes positive, tangent times tangent is tangent squared.
Oh, so you're just, okay.
And so then,
No,
these are like terms, so you add their coefficients, so negative 1 plus negative 1 is negative 2.
okay, I was getting confused, 'cause I thought you were just multiplying it, and 1 times 1, I don't know, I was getting off.
Okay, does that make more sense
Yeah, it
if I
does.
write it out? What happens now? We can combine because we have the same denominator. 1 plus 1 is 2. 2 tangent t and negative 2 tangent t cancel. Tangent squared t plus tangent squared t is 2 tangent squared t. Okay, look at our goal. We want the 1 minus tangent squared on the bottom. So we've got the bottom. On the top we need a 2. We've got a 2. We're trying to get a secant squared. What could you factor out of the top? That's 1 plus tangent squared t. What is 1 or plus tangent squared t? Secant squared t. That's one of the Pythagorean identities. So I think there's 12 problems in this section I want you to try. So you have 2 assignments. Tomorrow is just a work day for us, and then both due on Monday. Might not be a bad idea to